Okay, folks, as most of you have heard, we're going to go ahead and tonight's lesson is going to focus on functions. We're going to start off with just a simple function and then a little bit more elaborate function with temperature. These are all parts that you have in the kit and that little Arduino kit, the little red box Arduino kit. So playing with the RGB LEDs. So let's look at the hardware. Now, we'll get to hardware assembly and programming it, but let's just talk about binary color basics on an RGB and what it's doing. We can do all our colors with red, blue, green, i.e. yellow, white, cyan, magenta, blue. Now, can you figure out what this might represent, these colors? The numbers. Red, notice, is 100. Green is 010. Blue is 001. Any idea what that would be? Go ahead, you can answer with a question if you'd like, or chat with me a little bit. Come on, folks, what do you think the 001? A hint. What 1 and 0 usually represent on and off. Anybody have an idea? Let's see here. Let's see if we got any raised hands. Raise your hands if you have suggestion. Okay. Nicholas thinks he's got one. All right. What do you think it is, Nicholas? Nick? Yeah, there you go.
Red is the third one, the green is the middle one, and the blue is the last one. And the white is all three of them.
Very good. Nailed it. Good job, guys. So basically, this RGB is imagine almost like 3 LEDs in here, all right, combined together. We're going to power them up separately and then combine them to make all kinds of colors. All right, let me go ahead and mute Nicholas down a little bit. And so right here it is. Red is just that one's on, and then green, you can start playing with these different things. I'm not really that table, ignore that table right there. In fact, let me go ahead and get rid of that table. That slide. Delete that slide. All right. Because of the way we're programming this, it's going to confuse things more than help. Okay, so what I need you to do, pin 9 is going to the red RGB, pin 10 off your Arduino, pin 11, and they're all sharing a common ground. It looks something like this. So there's your ground, there's your red, there's your green, and there's your blue. And blue's going 11, 10, red. So we've actually made them colors to signify the RGBs. If you don't have a kit, go on 123D circuit. If you do have a kit, go ahead and set it up. There's a value to always physically setting these things up. Raise your hand once you have it set up, or raise your hand if you're not going to use 123D circuit. I'm not setting it up. So we don't sit and wait for somebody that's never coming. If that makes sense. This Mechatronics, folks, let me just stress how important. This is really behind automation. Robotics makes up a portion of Mechatronics. And there's really very much demand for people to do what's also known as embedded programming. Or if you're an electrical or mechanical engineer, to do it that way. All right. We got a couple hands raised, but let's give you a few more minutes. Go ahead and just raise your hands once you have it. My computer says 811. Let's see if we can get these hooked up by 815. Those are 330K resistors in your pack. Don't confuse those with the 10K. 10K will, LEDs aren't turning on if you've hooked them up to 10K. All right, looks like we got just about everybody else hooked up. Nice. Okay, let's go on to the next bit of code. All right, and again, those are 330 resistors. So first of all, start a new sketch. Call it something that's appropriate. RGB, my RGB, something. And I would, if I called it my RGB, it'd be lowercase my, uppercase RGB. I wouldn't put dashes. Keep it simple. And in it, we're going to use constants. Constant, that means you're not going to change it. It's going to stay this way in the program. Normally, that's what you do. It's considered bad form to be changing it because it's a constant. So constant, what kind is it? It's an integer. We're going to call it red pin, and we're going to assign 9. So it's going to be the 9th pin on there. Green pin 10, blue pin 11. In case you're wondering where that's from, there's the red pin is going to be 9. This digital pin is 10. This digital pin is 11. Okay. I'm going to put everybody's hands down. Let me know once you have this code so we can go on to the next one. You should have started up sketch. You're putting in your sketch. And the first 3 things, this is outside of the void setup loop, outside the void loop. Void loop. Outside of void setup, outside of void loop. All right, getting most everybody. Good job. Give you a minute to finish this up. Constants in Sketch, the standard is you write in all caps. You wouldn't have to. It still would run as another name, but it's just a good habit to follow the same standards, because if someone's helping with your code or you're trying to figure things out, if they are familiar with Sketch, then in Arduinos, they're going to recognize that as a constant. And it's amazing how much you forget of this if you come back, 3 months later to work on it. You go, oh, what was that? Okay. Good job, folks. Let's go on to the next one. Everybody's hands down. So then this next line is, this is a time, this is a variable loop. We're just going to put in there how fast we can loop through the colors. And so we could do that. Okay, I'm going to go on since we can see it up here. Now, what's going to happen is, up here, constants. Here's another constant in 10 seconds and milliseconds. It says pin mode, red pin output, pin mode, green pin output, pin mode, blue pin output. So you're defining those 3 pins we just created as outputs. And then your program is really in void loop main colors function. Now, if you go on SparkFun's site and you look up RGBs and Inventor's Kit, they actually have some more functions associated with the RGB pin and that's where we use display time with. We're really not going to use it on this because I just wanted to do a very simple function for you guys to get a sense of this. Notice this is a great big function. There's no semicolon. When we're calling a function, main colors, parentheses, parentheses, colon. We create a simple function to call main colors to cause the RGB to turn 8 colors. All right, raise your hand when you have this. This should have been you've already done. This you've already done. This is your new thing to do right there. Go ahead and do that. Raise your hand once you have it. And if you go again to the SparkFun where you got the kits, go to their tutorials, you do RGB, you'll see where I'm getting this code from. Okay, we're just waiting for a couple more here. There's a lot of code there. I totally get it. And again, you can do this on 123D circuit if you don't have the hardware. And again, if you got here and you didn't hand down handouts, make sure you do that. So in a minute here, as we finish up, everybody raise your hand once you have this first page of code. What has to happen next is we need to write the main color function. And that's going to be outside of this void loop. We're going to call this function from within that loop once you're in it. Think of functions as just a little bits of code that's stored, and you call up that bit of code whenever you call the name of the function. All right? So let's do the first loop of this. Void main colors. Notice this time there's no semicolon, bracket. And what I would suggest is we do the test this right now. Well, let's go back up. You can imagine we're going to do a lot of colors there. But what I would suggest is do an open container left and then a right-handed here and run it, see if you get black, see if you get red. All right. I think you're looking for red, basically. You're looking for this flash off. I would do that to make sure it's going to work. Let's see if you get red, and then we'll add some more. And you can let me show you where we're going with this. Remove the bracket if you go to add more code, and then you power up green by just turning the high, and then blue. So let me go back to that first. Black is the red pin is low, the green pin is low, the blue pin is low. These are all digital writes, it's not analog. The red pin is high, the other two are low. And you're delaying a second so you can see the difference. When you want green, not surprisingly, that's low, that's high. Blue, low. This should be low as well. This should be, wait a minute. Let me go ahead and change this. This should be low as well. All right. And so that's blue and that's high. And then what makes yellow? Well, that's red and green high. What makes cyan? Well, that's green and blue high. What makes purple? Red and blue high, and then white's all three of them. And then underneath here, you would also have a bracket. You would be all set. Let me go ahead and make that bracket there. I want to make sure I get that right. So those brackets are all set up there. Good. And in fact, I'm going to replace and download that. I'll put this PDF. While you work on that, I'm going to go ahead and freeze the screen for a second while I go ahead and download that again. There we go. Okay, those have the corrections on them. Back to here. So when you get, I'm going to put every something last time. When you get your LEDs going, changing those 8 colors, raise your hand. Very nice. All right. All right, we got most everybody getting it to work. Got just a couple more people. Give them a chance. And really, again, all you're doing is turning 2 of the pins on and setting the 3rd pin low. If you do all 3 of them on, you're going to have white light. All 3 of them on, it's going to be black. There's you know, it's off. That's no shock there, I suppose. Daniel, do you have yours working? Okay, that answered my question. Just as I was saying it, he clicked on there. All right, I'm gonna here. So that's basically what we have with the white. Most people have got it. I'm gonna put your hands down now. Remember to download that color RGB spring if you need it, and the other ones. Raise your hand if you think after February we're gonna have webinars tonight, Wednesday. If we did one again, maybe towards the end of this month or beginning of March, would people be interested in that? Just to kind of answer questions or do anything? Raise your hand if there'd be interest for doing that. Okay. We'll try to get myself or Tom will try to take over on that. Well, Tom, are you ready to go ahead into the other one on the temperature sensor?
Yeah, I could get started on that.
Yeah, I think if you can try to get through it in the next 30 minutes, that would be great. And then we can talk flex sensors and soft pots, the last webinar, and just answer any questions you've got on programming. I'm going to leave mine running. I'm going to be recording on my end. Hopefully you're recording on yours as well, so that way we can post this. All right.
Yeah.
Good luck, guys. All right. I need to hand you the screen, don't I?
Yeah, I think I can take it though.
Oh, okay, good. You're probably right. So you go ahead and take it whenever you're ready. Okay.
All right. So, you guys just went over RGB LEDs and got them to light up all kinds of different colors. I'm going to have you rip all of that wiring out because we're going to rewire everything already because we're about to go over temperature sensors. It's about to get hot. So, basically, it's going to be real quick. We're going to go over what temperature sensors are, what the circuit is, and then the code for it. And the code involves less typing than what you just did, which is also good news. So a temperature sensor, as you might imagine, measures ambient temperature. I mean, that's no real surprise there. I'm going to put the hands down. The temperature sensor has, has 3 pins. It has a positive, it has a negative, and it has a signal pin. The positive and the negative, power and ground. And then the signal pin sends a voltage out depending on the temperature. A change of 1 degree in Celsius is to a change of 10 millivolts. So that's how the temperature sensor relays its information to the Arduino. As the ambient temperature changes, the voltage coming out of the temperature sensor changes as well. The Arduino can pick up on those changes, and with some coding witchery, we can turn that into usable information that you can see on the screen. So it can say like, oh, it's 75 degrees inside your room right now, something like that. So that's the whole idea behind this. A temperature sensor kind of looks like a tiny little, or it looks like a transistor. Actually, I've got a bigger picture of it here, so you guys can see exactly what it's supposed to look like. It's got the 3 pins. You've got a positive, you've got a negative, and then you've got a signal pin. And then the way you can differentiate it from the transistor is the fact that it's got this little engraved triangle on it. And then it also says TMP. That's really, it's the most obvious thing telling you that the temperature sensor is going to have the TMP on there. So those of you who have your kids, why don't you rummage around for that, find it, and grab some wires, because I'm about to put up the wiring diagram. And those of you who are on 123D circuits, well, your life is a little bit easier because all you have to do is type in temperature sensor into a little search bar and get that hooked up. But here is what the, well, no, that's what the different things look like. Here's the schematic. Here is what the wiring diagram is going to look like. Just go ahead and bring that up for a moment. And, you know, it's a pretty simple diagram. You don't have to deal with any resistors or any LEDs or anything like that. We're going to worry about the output through the serial monitor on the Arduino. So that makes life pretty much easier. So if you guys can just raise your hand once you've got this built, either in 123D Circuit or on your breadboards at home with your SparkFun kits, then we can continue. All right. Got one hand up already. Two hands. You guys were faster at it than I was when I was hooking it up. 3. Just about everybody. All right, give you guys another 1 or 2 minutes to finish it out, and then we'll move on from there. But like I said, it's a simpler circuit, which is good news, right? I mean, as far as getting it set up quickly is concerned. All right, so let's go ahead and now that we've gotten that down, let's start taking a look at the code. So bring it out of present mode so I can start typing along with you guys. So we got a few things we're going to get set up here. Obviously, you're going to have some kind of variable for the pin, like you always do. I mean, that's pretty much a given at this point. So let me go ahead and do my void setup. And void loop, another given in pretty much every Arduino program. And let's do this constant integer. So it's going to be const int temperature pin. That's a pretty reasonable name because we know we're going to be taking in the temperature, right? So we're going to call it temperature pin. And it's going to be a constant integer variable. Again, like the RGB LED pins that we had in just the last one. So now we're going to, because we have to set the pin mode to something, we're going to set that temperature pin to be an input pin this time. So do the pin mode like we always do. Temperature pin is going to be our pin, except this time we're going to set it to input because it's going to be taking in information. We're going to be taking in information from the outside world and sending it into the Arduino. And I'm not really sure on this. Have you guys messed around with the serial function before in the Arduino? Has that been a thing? Okay. I see one hand up. All right. Well, so you guys should be pretty much familiar with this next command that comes around, the serial.begin. If you haven't messed around with it, basically it's a window that can be used to show information from the Arduino to the computer. And the nice thing about the serial window is we can determine what is displayed there, so it can be exactly as helpful as we want it to be. Of course, the flip side to that being, if you neglect to put helpful information into the serial print, then the serial window is not going to be very much use to you. But regardless, we are going to use the serial window because that's how it's going to give us the temperature. So let's go ahead and put in a serial begin. And the 9600 is just basically the communication bit rate between your computer and the Arduino. And that just means how fast they talk to each other, how much information is sent, and how quickly it sends information. That's really all it comes down to. So now we're going to start putting stuff into our void loop. Our void setup is done. We don't need to worry about anything else about that. We've already got our constant integer set up, so that's all good to go. Now in void loop, what we're going to do is we're going to set up basically the equations that we need so that we can convert the voltage that comes from the temperature sensor into a readable temperature on the Arduino. Let's go ahead and put in some floating point variables. One called voltage. We'll set it equal to 0.0. One called degrees C, 0.0. And one called degrees F, 0.0. Why do you think we're going to do a degrees C and a degrees F? And if you have an answer, you can just throw it into the question box. Yeah, exactly. They corresponded to Celsius and Fahrenheit, respectively. Because the voltage corresponds to a change in degrees Celsius, we can use a conversion in order to change it from a voltage value to a temperature in degrees Celsius. Because we live here in America and we use freedom units, we have a secondary conversion to degrees Fahrenheit, which you guys are probably much more comfortable and familiar with growing up. Getting into engineering, depending on what branch you're going to go into, you're probably going to get very familiar with the metric system in there too. But for now, it's always good to have some sort of benchmark to work off of. You can get rid of the conversion to Fahrenheit in this code if you want to get yourself more comfortable with degrees Celsius, or have both of them display or whatever. But for now, we're just going to have both of them in there. So now an equation. So we need to get the voltage right. We need to set it equal to something. We're going to do that by creating a custom function called getVoltage. Let me just go ahead and scroll back over here. So voltage is equal to getVoltage, and then we're going to pass a temperature pin. So this is a custom function called getVoltage. You should be familiar with this just even from the last thing you just did. And we're going to pass it a temperature pin value. And you're going to see why we pass a temperature pin in a minute. Once we get that information, we're going to get our degrees Celsius by taking the voltage we get up here, subtracting 0.5 from it, and multiplying it by 100. Basically, we're just doing some math wizardry to it so that we can turn the voltage value into a temperature value. Now, how do we get this conversion bit here? I mean, that seems kind of arbitrary, right? Well, you've got these wonderful, wonderful things called datasheets. Datasheets, you can take the serial number of a little doodad or whatever, plug it into Google, put the word datasheet after it, and pretty much 99% of the time, the first result is going to be the datasheet created by the company that made the component. And these things are amazing. They're going to have so much information on them that you can use, what temperature they operate at, the maximum amount of voltage and amperage they can take in, what kind of output they give out, what the different pins do, what the thing is supposed to do. I can't tell you how many times there was some sort of anonymous little microchip in the lab that we were all sitting there puzzling over, going, I wonder what this does. And until somebody finally plugged in the serial number and datasheet, and then it was like, oh, okay, it's a little clock that allows us to calculate milliseconds or something like that. Whatever the case may be, it helps out a lot in demystifying these little, black and silver components that you have floating around inside of your kit and out there in the great wide world of electrical engineering. So datasheets are wonderful for that sort of a thing. It's a really good idea to get sort of familiar with them. A lot of it's going to be probably information that you don't necessarily get at first, and that's okay. There's always going to be some sort of nugget of information on there that's going to be applicable to what you're looking for, and then you can use it. And as you get more familiar and comfortable with electrical components and things like that, a lot more of this stuff will make sense to you, and you can glean a lot more information from data sheets as you look them over. But for now, it's good to know that they exist in case at some point in the future you're ever working with something and you're not sure how it works. Anyway, long story short, down here in the general description, they give you a relation between the change in voltage and the temperature in Celsius. So by working backwards from that, we can give ourselves an equation for degrees in Celsius. And that's really all there is to it. So now that we've got the Celsius, let's go ahead and put in the equation to convert it to Fahrenheit. And because I'm terrible at remembering things, okay, yeah. So this is going to be degrees Fahrenheit is equal to degrees Celsius times 9.0 divided by 5.0 plus 32.0. And of course, chemistry will tell you the conversion between Fahrenheit and Celsius and vice versa. So another quick Google search could give you the answer to how we got that if you weren't already familiar with it, that sort of thing. Chemistry and physics and things like that. Take those classes. A lot of times they'll cover the conversion. So now we've got our three variables. We've got voltage, degrees in Celsius, and degrees in Fahrenheit. We've got a function call for a function we haven't created yet, which will give us the voltage. We've got a conversion that will convert that voltage in degrees in Celsius. And then we've got another conversion that will convert that the degrees in Celsius to degrees in Fahrenheit. So far, so good. Now we need to print all that information to the serial window so that when we plug in the Arduino and start running it and stuff like that, we'll actually get some output to the serial window that we can, see. So that's done with a bunch of serial prints, all in a row. So what we can do is we can go serial.prints, not pring, because that's not actually a word. I started typing Pringles, I think. I'm not entirely sure, but what we want to type is prints. And then a string literal. Our string literal is basically just a fancy word for put this exactly onto the screen. That's really all it means. When somebody's telling you about a string literal, what they mean is like when you had to do, maybe you had to do dictation in elementary school in order to get used to like handwriting and stuff like that. I don't know if you remember that. I don't know why I remember that. It just popped in my head. But somebody would say, write this sentence out exactly, and you have to write it out exactly. Punctuation, words, and all. And that's the same thing that we're doing here. We're just saying everything inside of the quotes printed onto the computer screen exactly like how we typed it. And that's useful for labeling things. So serial print voltage. Serial.prints voltage. So now we're printing out the contents of the voltage variable. That's all that is. So we're saying the word voltage, a colon, a space, and then the stuff that's in voltage. Same idea here, except we're going to put like 3 spaces, and then we're going to type degrees Celsius. Oops. Put another space, a close quote. Doesn't really matter how many spaces there are, just as long as there are some, so it's easier to read. This is really just formatting it so it makes it easier for you to read. And then we're going to print out the contents of degrees Celsius. I think you get where I'm going with this. Another one for degrees Fahrenheit. And then finally, degrees F. Bing, bang, boom. We've set up all of our prints so that now, every time the Arduino cycles and pulls in new information, it's going to print out the voltage, it's going to print out the degrees in Celsius, and it's going to print out the degrees in Fahrenheit, all with this nice labeling system that we created. If it's kind of hard to see now, it'll make more sense once we pull up the serial print window. And then, finally, we've got to have a delay command in there, just so we, as normal puny human beings, can read it, because otherwise it would go way too fast to read. Even still, it's going to be a challenge with only 1/4 of a second between refreshes, but you'll be able to get the idea. And I apologize. This last serial print should be a serial print line. That's what that LN stands for. It just means that you put a line break at the end. You go down to the next line and print the next thing. That's so that it doesn't all print on one line. It makes it a lot easier for us to read it. So now that we've created all that stuff in loop, let's go ahead and create our really super complex get voltage calculator function thing. So this is going to be a float function, because it's going to return a float value back into voltage, right? It's sending a value back into voltage. So we put the float keyword in front because it's going to send back a value. And it's called get voltage. And it takes in an integer called temperature pin. Or actually, we'll just say integer pin, like it has here. It'll save us some typing. So we've got float, get voltage, integer pin. Set up much like what we got up here. There's only a single line in our get voltage. It's return. So all we have to do is just return the value of a calculation. And what it is an analog read. Whatever's coming in through pin, it's going to be an analog value coming in through pin, and then we're going to multiply it by this value. And the reason we're multiplying it by that value is because the stuff that's going to come in through pin is going to be a little bit different than the voltage value we actually need, and so we do a little bit of math to it so that it's a value that we can work with. But that number, I'm actually going to put into the chat box because it's a bit of a long number, is 0.004882814. Some of it has to do with the strangeness of voltage fluctuations between the temperature sensor and the Arduino, and how the temperature sensor reads things, the way its voltage can change based on the temperature changes and things like that. It's sort of like a normalizing value. That's really all it is. It's just so our voltage value and subsequently our temperature readouts, or temperature values, are closer to what they actually are in real life. And that's it. This code right here is all we need in order to get our temperature sensor running. So let me go ahead and plug in my Arduino. I had to do the whole USB shuffle where you flip it over a couple of times until it plugs in properly. Make sure we've got the proper serial port selected. COM4, excellent. And of course, my Arduino is not going to cooperate, so let's go ahead and save this real quick and then reboot Sketch so that it will work with me. All right. Got it plugged back in and everything's working again, so let's go ahead and get it uploaded. COM4, access is denied. Okay. A little bit of troubleshooting is in order then. Let's see what we got here. Seems like I don't have sufficient permissions in order to communicate with the computer. And this isn't going to work. Sorry, I keep moving the window because it forces it to refresh so I can actually see the, yeah, that's what I thought. See the results. It's probably kind of annoying to watch, and I apologize for that, but it means that I can keep an eye on the status of the Arduino. Done uploading. Cool. So now if we're to open up the serial monitor, look at that. And it's probably giving me a, nope, it hasn't. Oh, there we go. It just took a second to update. If I move this window around, the serial monitor updates. And let me go ahead and expand it. As you can see, it's a nice, balmy 80 degrees inside of my apartment, despite the fact that the heat isn't running. Is it a temperature sensor TMP36 or LM35? It is. Check the data sheet. It is a TMP36. Just double check it here. On there. I don't have enough light here in order to be able to see it. But go with the TMP36. But anyway, yeah. So this will update itself every quarter of a second with new information. As you can see, it's fluctuating a little bit, but it's staying pretty consistent. Explains why it feels so warm in here. But this is what it will do. Eventually, you can spend some time getting familiar with the LCD screen that comes included in the SparkFun kit too. So you can get that hooked up so it's got a readout right on the LCD screen. And then the next time you tell your parents that it's cold and they tell you, no, it's not, suck it up, you can actually point to the LCD screen and say, yes, in fact, it is actually cold. Can you turn on the heat? That's pretty much all there is to it. No problem. Any questions about anything? Okay. Well, if you do, feel free to type it into the question box. Otherwise, I think I'm going to defer to Mr. Dubik right now to talk about what we're going to do on Wednesday and what all that's going to entail. Well, at any rate, we could do the, I guess you guys don't normally do poll questions? Okay.
Right. We don't, Tom?
Yes.
All right. We're, I think we're set. Does anybody have any other questions right now? All right. what we'll do then is we have one more meeting this Wednesday, okay, folks? Let me just take a quick survey here. We'll do this. I don't have control of it, but that's all right. Raise your hand. Are you finding? Let me go ahead. I can't get on my. Let me see if I can get on my screen here. Or bring up the hand counts so we can see, just so we can both see what the hand looks like. Folks, raise your hand if you've been finding these things very useful for you. I'm planning on sending out a survey to everybody on a couple questions long, so that's why we're doing it that way. All right. Since you've got the functions now, is there any other questions? Well, if there's not, we'll see you Wednesday. One last question before you go. How many people are going to come back in Wednesday night? Again, Tom, I hope you're looking at these things because I don't have that ability right now.
Okay, yeah. Yeah, pretty much everybody. I do have a question from Randy here, though. So there are a total of 5 handouts for the entire webinar series?
Yes, right now they are, because some of the webinars went more than one. All right. Now, probably the last webinar, we will be going over soft pots and a couple other little devices, flex sensor. So we'll drop one of the handouts then. But we'll have them, and I'm going to go ahead and share with everybody that signed up for the webinars where you can download all these PDFs. Well, if that's everything, I guess we're set for tonight then. Do you have anything to add, Tom?
I do not. There is another question here. It says lessons 1 and 3 are on YouTube.
We will go and see where they are, and we'll post them back up.
Okay. Yeah, we'll get that handled. Yeah, I don't have anything to add on my end, though.
Okay. And if you go to 2015, which is on the website too, that has the first webinar. Those webinars are pretty identical, but we will make sure, even if I have to re-record the lesson 1, somebody else said there's a problem with 1, so I'll re-record 1 and whichever ones we need. Okay, folks? All right. With that in mind, all right. Take care, all.
Have a good one, everybody.
Tom, let me know once you're logging out. Well, getting ready to log off.
Okay, yeah, I'm ready to go whenever.
All right. I'm glad that's turned off. All right. Excellent. All right, now let me see if my webinar is recorded or not. I think we're still on the webinar because we can hear each other.
Mm-hmm.
Okay, we have any students still up?
1.
All right. Okay. Let's see what happens. All right. Well, I'll tell you what. Let's try closing off the webinar. I'll give you a call after this. How about that?
All right, sounds good.
All right.